Hey everyone, it's James from Zygal Studios. Let's pick up from our last lesson in our homework 4. So homework 4 was basically just a counter and decision-making program using an if statement. So we have two variables, one that starts high, one that starts low. So I starts at 0, j starts at 1,000. So we increment to count I to 500, which is 0 index. Once I hits 500, we then need to count j to 500. So that means we need to count down. So j goes from 1,000 to 500. Now we want to count I to 0. So after that, we count I to 0. Once I hits 0, we need to count j down to 0 as well. So this was just a way to collect all the information we've kind of learned so far and put it into one program. Fairly easy. This is one way to do it. You can do it many other ways, but this is one. So now that that's over, let's get on to lesson 5. And lesson 5 is arrays. So now with arrays, basically, arrays are just essentially a collection. Arrays are a collection of ordered data items stored contiguously in memory. So it allows you to collect a similar data type in one group of memory in a set. So think of an array as just a giant line of the same data type stored one after another. The syntactical sugar in C is described here. You have the data type, the name of the array, and then the size. And this goes for all the basic data types. Int, character, uint32, they all have the same collection in memory. So how is it stored in memory? In theory, of course, because contiguously means stored one after the other with something in between. So basically every other spot is taken up. But we're not going to get into that. That's more computer organization and architecture. Maybe in a future video I'll cover some topics on that. But for right now, let's just stick with C. Just think of arrays as a collection of data in a line. Just think of it as almost like a number line, but there's cutoffs in between. What do I mean by that? So let's assume there's an array of 8 integers. So we have size of 8, so that means there's 8 elements in this array, and it's of the type integer, so it can go to that specific maximum and minimum value. So as you can see here, this is our imaginary memory table. So we have 1, 2, 3, 4, 5, 6, 7, 8 elements. And they're all stored in a line. So this starts at address here and ends at address here because we have 8 32-bit values, which goes out to, of course, 256 bits. And that is exactly what we have here addressed in memory. So if we're thinking about index... So if we're thinking about an index here, this would be array 0. So once again, let's be careful because arrays are 0 index, meaning that the maximum value you can go to in this array is 7. Because if we start at 0 and count up to 7, that means that we have 8 elements. If we started at 1, which it doesn't happen in C, things are 0 indexed, we would overrun the array and create what's called buffer overflow. And this is a very, very dangerous piece. You can either create a segmentation fault in your program, or it opens up opportunities for, well, malicious code injection. So basically, you don't want to do that. You want to make sure that your bounds on your array are tightly locked, meaning don't overrun this piece of the array. I'm not going to get into how the stack works and essentially what happens in detail, but all I'll say is for right now, make sure your index that you reference is never over 7. So it basically goes from 0, and then this element 0 here at the end would be referenced as this. So this would be element 0, this would be element 8, or 7 in this case, I guess, so the most significant. So that's how they're stored. So now, here's a tricky thing. If you just do this, the C compiler will take a random slot of memory and assign 8 slots of the data type that you have and just put a pointer, which we'll talk about in a future video, put a reference to your array so it knows where it is, and you're essentially guaranteed nothing. You're just guaranteed whatever's in memory. So it could be junk. It could be anything in here. It could be junk. It could be this number. It could be that number. You really don't know. And so this is why we want to go to the next line now. In C99, this initializer, the delimiting quotation marks, initializes all elements of that memory location to 0. So this is the difference between the two. So you have undefined behavior if you just define it like this, but if you define it like this, Now you have all your elements at 0 and you can work from a clean slate. So now what if I want to assign different values of the individual indices of the array on runtime? Well, I can do that too. So right here I can initialize each one of these slots, like how we talked about here, to individual numbers or characters or unsigned numbers. It doesn't matter. You can assign whatever you want as long as you put brackets and commas in between each index. If you do that, this is what it looks like in memory. If we just want to do 1, 2, 3, 4, 5, 6, 7, 8, this is what index 0 looks like. This is what index 7 looks like. Everything in between follows. Make sense so far? If not, pause the video, redo it, or you can ask me questions on Twitch. Multidimensional arrays. So this is where things start to get a little crazy, but I'm just going to introduce this concept for now. So multidimensional arrays are for things like matrices, where you have large sets of data that have rows and columns to them and are organized as such. You have to be careful because sometimes these are not stored the same way as single dimensional arrays are and can cause performance problems if you're not careful. You're better off storing two separate single arrays than you are making one multi-dimensional array. So, but essentially this is the concept. So you have rows and columns. So the columns are the second number, and in this case, so if we want two columns, if we want 2 rows, so just nice and easy 2 rows, but we want 8 columns, this is how we set it up. So rows, columns. Then each of the rows are delimited by brackets inside of 2 bigger brackets and then separated by commas. So if we want our first row to be 1, 2, 3, 4, 5, 6, 7, 8, and then our second row to be 8, 7, 6, 5, 4, 3, 2, 1, this is how you do it. Right here. And this is what this looks like in memory. So now let's look at some of this in practice, because now we have to kind of apply what we're learning here. So the cool thing about arrays is that you can access any single element of that at any time. So that means that if I want the third element of my 8-byte array, I can easily, 832-bit array, I can pull that value and check to see what it is. I can change it. I can manipulate it. You can swap elements between different arrays. You can use for loops to increment between the beginning and the end of arrays to essentially do what you want to do. Okay, so let's say I have this array here, and I want to initialize it to 0, and I want to fill elements with 0, 1, 2, 3, 4, 5, 6, 7 through elements 1 through 8. So the first thing to note here, this means -1 of this number will be your max element size of the array. So that is very, very, very important to note. If you put 8 here, this will then assign the next thing lined up in memory or put on the stack. So it could be even a variable that you initialize here that it will change, and it will just change and undefined behavior will happen. So programs can crash, you can create a seg fault for yourself, you can change values of things without knowing and have weird bugs. Off by 1, it's called an off by 1 error. Listen to Smokey the Bear, only you can prevent off by 1 errors. So we want to make sure that we do not overrun either bounds of the array. And the same thing goes if you count down. So if you count down and go past 0, you go to the other side of the stack. And then you start overwriting values there or create issues there. So let's make sure we're doing it safely. So practice safe array indexing, kids. This is important. Start at 0. That's acceptable. End at 7, that's acceptable because 8 minus 1 is 7. We want to increment I. We want to assign I, at array at index I, so we'll go through 0, 1, 2, 3, 4, 5, 6, 7, to the value of I, which would just be 0, 1, 2, 3, 4, 5, 6, 7. So in memory, it should look like 0, 1, 2, 3, 4, 5, 6, 7. So now, this is important once again. So let's check to see if our array 3 is equal to 3. If the element of array at 3 is equal to 3. Haha! So in this case, it is, and here is why. We are 0 indexed. So this means that array 3, the index of 3, is actually 4. Because you can't access, if you access 0, this would be, well, 0. If you access 1, it's 1. If you access 2, it is 2. Okay? So that's kind of the idea here. So you have to be careful. So now let's say we want to access 2 because we think element 2 is really 3. 0 index, right? Not so. It's 1 behind. So this is just to kind of give you a general overview of what arrays are and how they feel. All right, let's move on to the homework assignment for this week. So the homework assignment, once again, this will probably stretch you guys a little bit, but let's continue on with that. Define 2 30 by 30 matrices of values, so it doesn't matter what they are, but 2 distinctly different matrices. Don't make 2 the same, make 2 different. Doesn't matter if one value differs or doesn't matter. Make sure the values are not exactly the same. Swap the contents of both 30 by 30 matrices. This is going to require use of for loops. This is going to require use of arrays. And you could use if statements, but I'd suggest not. Just use what you've learned so far to write this program. So I want to thank everybody for watching continually. I really hope this is helping out. And I'm going to take this time now to talk about my Twitch channel. My stream schedule is Monday, Tuesday, Wednesday at 6:30 p.m. Eastern Time of the United States. I would really appreciate if you guys could follow me. It's free, and it's a good source of information. If you have C questions, feel free to ask me. Even if I'm playing games, I will be happy to answer. And if you need help with any of the problems I have, I will gladly set aside office hours or a new stream schedule on Twitch in order to do so. The links to my social media are in the description below. Thank you so much. Please remember to like, comment, and subscribe. I appreciate all the support, and I'll see you for Lesson 6. Remember, kids, practice safe array indexing and keep those fingers loose, because next week we got a doozy. This is James from Zygal Studios, signing off. Hey everyone, it's James from Zygal Studios. So thank you for watching my tutorial on how to program in C. There's going to be more videos coming in the future, so if you could hit the subscribe button, I'd really appreciate it. I've wanted this series to take off for a while, so please, if you could, show some support and like and comment on the video if it helped you. If you guys have any suggestions for future videos, please put them in the comments below. Thanks so much, and hope to see you back here again soon.